Okay, Doug, we're ready to hear the latest on disc brake servicing. Al has offered to help. He's had lots of experience and will give us the benefit of his disc brake know-how.
Sounds great, Tech. Al, let's take turns at this. How about something on the fixed calipers for a starter?
Okay, Doug, but remember I'm only a helper on this job. First, let's talk about corroded cylinders and sticking or frozen pistons. The main causes are dirt and road splash getting past dust boots that are punctured, torn, or not properly installed. Jammed or sticking brake pistons can cause premature lining wear, a hard pedal, and reduced front brake efficiency because they can't retract properly. In addition, a stuck piston does not apply effective braking pressure on the shoe. As a result, when only one brake has stuck pistons, you can get brake pull toward the opposite side, the side with the more effective brake. If only one piston sticks, braking will be reduced, but little or no brake pull may be felt. If both pistons jam on one side of a caliper, the braking efficiency of that brake is greatly reduced. When only one piston sticks, lining wear is uneven and tapered, with the thick end over the seized piston. Now, before you remove a caliper for any reason, insert a metal bridge and force each piston back into its bore with plier pressure to check for free movement. When installing new shoes, you can make the job easier by pushing all the pistons back before you take the caliper off. However, forcing the pistons into their bores raises the fluid level in the master cylinder reservoir. So check the level first, and if full, remove enough fluid to prevent overflowing when the pistons are moved back. Any piston that requires excessive force or feels rough when forced inward must be inspected for corrosion. Now, for a good look, you'll have to remove the caliper from the car so you can pull the pistons out of their bores. Before you separate the housings, disconnect the caliper transfer tube so it won't be bent. The tube is routed over a ledge to keep it away from the disc, but must not be bent outward because it might scrape on the inside of the wheel. When working on a caliper, be sure to hold it in a vise with soft jaws so you won't damage the mounting or mating surfaces. You should never grip the housing in a way that can distort the bores or jam the pistons. With the housing separated, you peel off the dust boots and remove the pistons. The special tool must be used to draw the pistons straight out because cocking can cause serious damage to the pistons and bores. Use a pointed wood or plastic stick to remove piston seals. Screwdrivers or similar tools can scratch the bore surfaces or burr the seal groove edges, either of which can cause leaks. Discard used seals and dust boots whenever pistons are removed. Pistons which are pitted, scored, or those with the chrome plating worn through must be replaced. Lightly scratched or rusted bores can be cleaned up with crocus cloth. Those with deep scratches or scoring can usually be restored by honing. Now, of course, you've got to wash the parts afterward with clean brake fluid or alcohol to make sure there's no oil, grease, or grit in the passages or seal grooves. Always remember that oil or oil-based solvents will ruin seals and other rubber parts in the brake hydraulic system. Most brakemen know that the caliper bridge bolts and mounting bolts are made of special strength steel, but a reminder here won't hurt. The important thing is to reuse the same special bolts and to torque them properly so they won't stretch or loosen. And before I forget, if the brake hose retaining clip is not installed properly, it can catch and pull loose. Just make sure that the open end of the clip faces away from the caliper when you install it. How am I doing, Doug?
Real good, Al. But don't overlook the importance of checking the run-out and thickness variation of the disc before you reinstall a caliper or when there's a complaint about excessive pedal travel or brake roughness. As you know, too much disc run-out knocks the pistons back into their bores, increasing the running clearance of the linings. This unwanted clearance must be taken up before the brakes apply, so the pedal has to move farther than normal. In comparison, brake roughness or pedal pulsation usually results from excessive variation in disc thickness. In this case, the pistons move in and out with the disc variations, causing pedal pulsation and brake vibration. And Let's not forget that accurate disc run-out checking and good brake operation are both affected by wheel bearing adjustment. If the disc wobbles because of loose bearings, the effect can be the same as with excessive run-out or thickness variations. In addition, a fixed caliper disc should be replaced if its run-out exceeds specifications, so wheel bearings must be set at zero clearance to eliminate indicator error. If the disc is okay, be sure to readjust the bearings to the normal setting, or they will be ruined.
Before you get off the subject of fixed caliper brakes, do you have any service tips on the Cricket and Colt?
Yes, Tech. For one thing, you may find front brake linings worn prematurely on some Crickets as a result of no brake pedal free play. You see, if the pedal stop collar compresses when the stoplight switch is adjusted, there is no pedal free play and brake drag results. Here, you discard the collar so you can get correct pedal clearance. Equally important, the brake pedal must have free play so the compensating valve in the master cylinder can open to relieve system pressure and permit full shoe retraction. If a small amount of pressure is trapped in the system, the brakes can drag and cause excessive lining wear. Incidentally, the Cricket brake warning switch does not reset automatically. Once the reason for pressure loss in either system is corrected, bleeding the other system allows the higher pressure to move the switch piston back to neutral position. However, when the brakes are bled for any reason, the job must be done carefully, following the procedure given in the service manual. If too much pressure is applied, the switch piston may be forced out of or past neutral position, and the warning light will stay on. On some Colts, you may get a wire brush squeal, which is heard when starting to roll or while driving at slow speeds. In these cars, you simply invert the shoe cross springs to put the long ends down instead of up. Another Colt condition is a brake warning light which shows a dull glow even though the switch piston is centered. Usually the cause is an internal short circuit, which can be corrected by installing a new switch terminal. No bleeding is necessary. Can you think of anything else, Al?
Nope, not right now, but I'm ready with a good fix for noise in floating caliper brakes on cars and light-duty trucks. This is a high-pitched squeal. It sounds off on light brake applications at speeds below 40. The usual cause of this particular brake noise is a vibrating metal-to-metal contact between the back plate of the outboard shoe and the caliper fingers. Of course, such things as badly worn linings, scored discs, worn guide pins or pin bushings, and corroded pistons can also cause noise. But where the cause is vibration, we remove the caliper and apply contact cement to stabilize the outboard shoe. However, before removing the guide pins, pry the piston back into its bore so the caliper will be easier to reinstall. Insert a bar into a pocket in the disc rim and pry against the outer side of the caliper hole, being careful of the dust boot. Remove the outboard shoe from the caliper and clean the dirt and rust from the steel backplate of the assembly. You also clean the inside surface of the caliper fingers, which bear on the shoe.
Use medium grit sandpaper, emery cloth, or a wire brush to clean the metal surfaces so the cement can make a good bond. And be careful to keep grease and oil away from the lining surfaces, or the job may bounce back with a hard pedal or brake pull. Now hold up a minute, Al. We're at the halfway point, so if someone will turn the record, we'll pick up our disc brake story on the other side.
Now, with everything cleaned up, you apply a thick coating of cycle weld cement on the back of the outboard shoe and the inside surface of the caliper fingers. Allow the cement to air dry about 15 minutes, or until the surface of the coating looks dull. Insert the caliper guide pins backward through the small outboard bushings so they extend in toward the piston about 1 inch. Then, align the outboard shoe on the pins and press the cemented surfaces together. To finish the job, pull out the guide pins, position the caliper on the adapter, and install the guide pins correctly. The cement attachment eliminates the need for the anti-rattle spring, so it can be left off.
And that's why you'll find new current model car and light-duty truck disc brakes without anti-rattle springs. Now, before we change the subject, I'd like to warn everyone that using masking tape or other substitutes in place of contact cement is not a permanent fix. Tape prevents metal-to-metal contact for only a short time, and then the noise is back. Doug, it's all yours.
Thank you, Tech. Now, you'll find that a punctured, torn, or improperly installed dust boot on a floating caliper brake can also result in piston corrosion. If you inspect corrosion, check the piston for free movement. Here again, you can make the job easier if you pry the piston back into its bore before removing the caliper. In fact, when relining, you can check for free piston movement and force the piston back to accept the new, thicker linings in one step.
And this is a good place to explain why the outboard lining normally shows the least wear. The reason is simple. The wheel practically encloses the outboard side of the caliper, so it's not exposed to as much gritty dirt and road splash. I've also heard that some brakemen are going at relining the hard way, by removing both the caliper and adapter just to replace the shoes. As everyone should know, you simply remove the caliper guide pins and slide the caliper off. And another thing, all hydraulic brake hoses should be inspected every 6 months on vehicles in general use and every 3 months on those in police or taxi service. A twisted hose that takes a set or rubs must be replaced. A cracked outer hose cover or seepage around the end fittings can result in early hose failure.
All good points, Tech. Now, to remove a stuck floating caliper piston, you can use brake system pressure as described in the service manual. But don't get brake fluid on the linings. Never use air pressure for this purpose because a stuck piston can break loose suddenly and cause serious damage or personal injury. If the bore is honed, piston clearance must not exceed 6/1000ths of an inch. To check the clearance, you leave out the seal and measure between the piston and the bore wall with a feeler blade. After honing, be sure to clean the seal and dust boot grooves carefully with a stiff bristle brush. Flush out all grit from the grooves and passages with clean brake fluid or alcohol, and wipe the grooves dry with lint-free cloth. Before you install a new piston seal and dust boot, fill the grooves with the lubricant packed in the seal kit. Also, coat the bore and new seal. This special lube is compatible with brake fluid. It serves as a rust preventive and makes the piston and dust boot easier to install.
And here's where I make my speech about the importance of keeping brake hydraulic parts clean. Any foreign particles in the system can cause scoring of parts and may also interfere with control valve operation. And when handling parts, remember that the slightest trace of oil will destroy seals. You see, hydraulic system seals work well with brake fluid, but will swell and distort when exposed to oil or petroleum-based cleaning solvents. Try leaving a piston seal in a pan of oil for a day or so, and you'll see what I mean. Before assembling any hydraulic parts, the careful technician will clean his hands to get rid of dirt, oil, or grease, which can cause contamination. Generally speaking, all seals, pistons, and other similar parts should be lubricated with clean brake fluid before assembly.
Well said, Tech. Now, be sure to install new guide pin bushings when you reline the brakes. New bushings restore the original braking and self-adjusting characteristics which are affected by the friction of the bushings moving on the guide pins. And before you install the relined caliper, be sure to seat the new guide pin bushings in the caliper holes. If you slip the inner bushings on the guide pins first, they expand larger than the caliper holes and will not seat properly. Be sure you install new caliper positioners on relining jobs, because the used ones remain closed up as a result of compensating for lining wear. In this condition, they cannot retain the inner bushings properly when the new linings are installed. Be sure to install the positioners with the stamped arrows pointed upward and the alignment tabs seated on the machined caliper surfaces. If not installed properly, the positioners can collapse when the guide pins are installed. Do we have time for something on system control valves, Tech?
Yep, and I'm glad you asked, because we should talk about the new one-piece control valve that replaces the separate proportioning and metering valves used on some 71 cars. In fact, it won't hurt a bit to review the complete control valve lineup on our current model cars and light-duty trucks.
Okay, Tech. Starting with cars, the Valiant and Dart fixed caliper system uses a combined brake warning switch and proportioning valve unit. The floating caliper system control unit combines a warning switch with metering and proportioning valves, except on station wagons where it's a warning switch with a metering valve. The switch and proportioning valve unit is the same one-piece brass-bodied assembly used on the 71 Valiants and Darts. The spring-loaded switch piston resets automatically. Except for the switch terminal, this unit is serviced on a complete replacement basis. The new switch, metering, and proportioning valve unit for the floating caliper system has a cast iron body which resembles the switch and metering valve unit used on all full-size 71 models and all 72 station wagons. Here again, except for the switch assembly, the valve is serviced by complete replacement. The metering valve section of the new unit blocks off the front brakes when system pressure is between 3 and 135 pounds. This allows pressure to build up at the rear brakes before the front brakes to provide good directional and braking control on slippery surfaces. The proportioning valve section operates as the name suggests. It regulates rear brake pressure and front brake pressure in proportion to prevent premature rear brake locking on hard brake applications. Here's what happens. On light pedal applications, the proportioning valve allows equal pressure front and rear because this pressure is usually not high enough to lock the rear brakes. However, in a hard pedal application, the valve reduces rear brake system pressure. In the warning switch section, a pressure drop on either side allows the higher opposing pressure to move the piston off-center, and this pushes the switch plunger upward. When the piston moves into the front brake section, it also opens a proportioning valve bypass to allow full system pressure at the rear brakes. The warning switch piston in this valve is not spring-loaded and is reset by hydraulic pressure. After the cause of the brake problem has been corrected and the brakes have been bled, the piston will recenter and put the warning light out when you apply the brakes with moderate force.
How about brake bleeding with the new 3-section valve, Doug?
Well, basic procedure is the same as before. In other words, for pressure bleeding, the metering valve stem must be held out to override the valve's shut-off action. However, on some models, air can be trapped in the rear section of their vertically mounted valves unless special bleeding procedure is used. First, you crack a front bleed screw and press the pedal to move the switch piston and turn the light on. Next, you bleed the rear brakes, then the front brakes, and finish by resetting the switch piston with moderate pedal force. The warning switch with metering valve unit used on current model station wagons works essentially the same as the 3-section assembly, except that it has no proportioning valve section. As in the 3-section valve, only the warning switch can be replaced as a separate part. Now, on light-duty trucks, B100 and B200 compact wagons and vans have a proportioning valve and a separate brake warning switch. The B300 compact and D100, 200, and 300 pickups have a warning switch only. The warning switches reset automatically, and servicing is the same as for passenger cars. Now, for one last point. After servicing either disc or drum brakes, make sure that the brake pedal is firm before you move the car. Anything can happen if the pedal goes to the floor on the first push.
Well done, Doug. You and Al really make a good team for putting our disc brake servicing story across. You touched all the important points and filled in with the fine details that help to make things easier for all our master technicians. Now that brings this tech session to a close. As usual, there's more on disc brakes in your reference books, so read them through. And be sure to give your new 72 service manuals a good going over, because you'll find changes in all sections. Don't miss the review frames that follow the sign-off. So long for now.